This tutorial is about Excel's correlate or correlation command, which produces a number between -1 and 1. -1 means perfectly correlated negatively, +1 means perfectly correlated positively, and 0 means no correlation at all. We use correlation to look at the relationship, the association between two variables. We are not implying causation. So look at the data set here. I've got index prices of chicken, beef, pork, and various other things for various years. Those years could very well be countries. The point is that the data points need to match up. So if 1993 was Vietnam, for example, then we would need to have the matching data for the two variables that we are trying to compare. Because what happens is that each data point is selected is compared to the next one to see whether as one goes up, does the other go down, do they go up together by the same amount. So let's take chicken and beef. The first thing to do is to make sure that there is have a look first at the relationship between the data by producing a scatter plot. Go to Insert, and there you can see Scatter, and a scatter plot appears. We can observe from this that there does seem to be a pretty linear relationship. As one price goes up, so does the other. This is more or less what one would expect. We can put a trend line on this by locating on any particular point. It doesn't matter which one, but as long as it's one of the data points. Go down to Add Trend Line, and a dialog box appears. Now we have various choices like exponential, etc., which you're very welcome to try. But let's just keep to linear for the moment. And then close, and there a trend line appears, and most of the data points do appear to be on that line, or very close to it. So we would expect that the correlation between the two would be quite high. As one increases, so does the other. It doesn't matter which is on the x-axis and which is on the y-axis. We'd have got the same result just by switching them around. To work out the actual correlation coefficient, or ppm, the command is equal, correl, and then the first array of data, so that goes from B2, because that's the top of the column where we had the chicken, and then down to B22, comma, and we compared it to beef, so that should go to C2 to C22. Close brackets and enter. And we see that our R value is quite high, 0.906913. That's very close to 1, and is what we would expect. An almost perfect positive correlation. There's a plus sign, which means that as one increases, so does the other. Now I'm going to change the data set to consumption of fruit. And we can see here amounts of fruit consumed over various years. Let's take, for example, see whether there's any correlation between the consumption of bananas and the consumption of apples. We always check with the scatter plot first, and we can see that they seem to be scattered around the place. Again, let's put in a trend line. Oh, I missed that. Where's the trend line gone? Add trend line. Doesn't seem to want to go. Anyway, oh yes, there it is. Yes, I missed it there, you see. It's horizontal, which means that there is a zero relationship between one and the other. In other words, as we increase on the x-axis, there is no change on the vertical or y-axis. We'll be dealing with this later in a subject called regression, but it would seem that there is very little relationship between the two variables. Let's test this with equals CORREL, and we had bananas, so that's D2 to D11, comma, against apples, E2 to E11, close brackets, and we have a very, very small number, 0.00, it might as well be 0. It's got a negative sign, which means that as one increases, the other goes down. But the relationship is so close to 0 as to be meaningless. So what I'm expecting with your work is that you find some correlation between expenditure on one and improvement on the other, but this does not necessarily imply a causation. It's just that the two things are happening together. Thank you.